On this video, I'm going to show you how to graph inequalities on an XY plane. I'm going to start with these two up top. Y is greater than -1. I want to shade all the points where the Y coordinate is greater than -1. So what I do is I start with going to -1 on the Y axis. Put a dot there. Then I'm going to go straight across and make a dash line because I cannot equal -1. So all the points on here, the Y is -1, but again, it's dashed because I cannot equal. There's no little line here. Now I want to shade the Y's that are greater than -1. So here it's -1, here it's -2, -3. This is 0, 1, 2, 3, 4, all of these Y's. These Y's are greater than -1, so I'm going to shade up here. So when we see Y is greater, we shade above. All right. Now I'm going to test these 4 points. 0, 0, right here. It's in the shaded region, so it's true. -2, -1. Back 2, down 1. This is a dash line. Dash lines are false, so I'm going to cross that out because it's on a dash line. 6, 2, over 6, up 2, shaded region, so it's true. 3, -6, over 3, down 6, not shaded, so not true. Over here, we have x is less than or equal to 3. So I go on the x-axis to 3, so 1, 2, 3, put a dot there. I'm going to draw a line across it. This one's going to be solid line because it's got the equal sign. And I'm going to shade where all the x's are less than 3. So right here, x is 3. Here, x is 4, 5, and 6. Here, x is 2, 1, 0, -1, and so on. These x's are less than 3. So I want to shade all these points because all of these points have an x coordinate less than 3. Now I want to state which of these 4 points are in the true area. So true area is the shaded region or the solid line. So 0, 0. Shaded region. -2, 1, shaded region. 6, 2, over 6, up 2, right there, that is not shaded, so that's false. And then 3, -6 is on a solid line. Solid lines are true. Solid and shaded. Okay, the next two are going to involve a different strategy. I'm going to have to use slope and y-intercept on this one, and a different strategy on this one because it has x and y on the same side. So for this one, I recognize that there's a y and an x. So the -1 is my y-intercept. So I need to go on the y-axis. So start at y equals -1 on the y-axis. And then we have our slope. So it's rise over run, so I'm going to have to go up 1, right 2. From that spot, up 1, right 2. And I keep doing that. I can also go backwards, down 1, left 2. And this is going to be a solid line because it can equal. I want the y's less than the line. So everywhere on this line, y is equal to 1/2 x minus 1. So I want to also shade the y's that are less than the line. So I'm going to shade below. So y is less, shade below. Now let's look which of these points are true. 0, 0, not shaded, so not true. -2, 1, not shaded. 6, 2, solid line. Solid lines are true. 3, -6, shaded region. Therefore it's true. This is a different style here. I have x and y on the same side, so I'm going to have to not use slope and y-intercepts, because I can only do that when y is by itself, like this problem. So instead, here I'm going to actually just find 2 points and determine a line through those 2 points. So the easiest 2 points to find when x and y are on the same side is finding the x-intercept and the y-intercept. So the x-intercept is when y is 0, and the y-intercept is actually when x is 0. So I'll start with the y-intercept. So I'll put 0 in for x. That's going to make this go away. So -3 times what number is 12? So if I don't know, I can type in 12 divided by -3, which is -4. So we know the y-intercept of this is 0, -4, right there. Then I can put 0 in for y. That makes this one go away. So 2 times what number is 12? And that's going to be 6. So then we plot both of those points. So 6, 0 goes here. I draw a line. It's going to be dashed because I cannot equal. So dashed. Then to shade, I actually have to test a point. So we're going to test 0, 0. So you take 0, 0 and you put it in x and y. And 2 times 0 is 0, and 3 times 0 is 0, and 0 minus 0 is also 0. So we get the statement 0 is greater than 12, which is false. That means that this dot, 0, 0, which I just tested, is false, which means all of these are false. So if all of these are false, then these are the true ones down here. So again, 0, 0 is false. We check that. -2, 1, -2, 1, not shaded, false. 6, 2, not shaded, false. 3, -6 is shaded, so that's true. We could also take any of these and plug them in and see if the statement is true or false too.